All right, it's time to start looking at some composite shapes and surface area and volumes of sort of shapes and partial shapes are sort of put together. So we'll start with this one right here. We got a basic rectangular prism with a half sphere or hemisphere on top of it. And we're going to find the surface area and the volume. Now, I often find finding the volume the easier of the two. So I'm just going to start with that. Of course, it's really important, just take it shape by shape, piece by piece, and then sort of put things together. So I'm just going to start with my rectangular prism type of thing right there. I'm going to make this thicker. And I'm going to find the volume for that. And that's pretty easy because volume for something like that is just length times width times height. And I have all three measurements. So that's really easy to do. So I've got the length and I've got the width, I've got the height. So it's 6 by 6, so that's 36 times 10 would be 360. So my volume for the box type part, that is going to be 360. Now for a full sphere, the volume for a full sphere, of course, is 4/3 pi r cubed. And the radius for that, you gotta be a little careful. It's got the 5 up there, but the radius wouldn't be 5. The radius would be 2.5, just half that 5. So I'm going to take that 2.5 and I'm going to cube it, and then I'm going to multiply that by 3.14 for pi, and then I will incorporate the 4/3 and get a volume, we'll round off, we'll say around 65. Now the thing is, I only have half of a sphere, not an entire sphere, so I'm going to cut that in half. I'm going to divide that by 2, and that will leave me with about, again, I'm going to round off, it's going to leave me with like 33 for the volume of the half sphere in the top. So all I have to do now is just put those two things together. I've got 360 for the box, and I've got 33 for the half circle on top. So I'm going to put those two together, and I've got approximately 393 yards cubed. For some reason they're in yards, but whatever. And that would be the volume of the structure. So now let's look at the surface area. So let's do a little division. All right. So surface area. Now, this one, you gotta put all the sides together. It gets kind of complicated sometimes when there's really, really complicated shapes. So just take it one side at a time, one part at a time. I like to label my parts and then sort of piece things together from there. So I'm going to start with my little component on the one side that's closest to me, the 6 by 6 square. And I often like to label my little parts so I can keep them organized. So I'm just going to label that just A right there. So I'm going to do section A. Now, section A is just a square. It's a 6 by 6 square, so the area for that would just be 36. And then what I like to do is I like to see if any other sides will match up to that. Well, I've got the exact same square on the other side as well. So I'm just going to double this because there's 2 of them, which gives me a total of 72 for that part. Then I'm going to look at the other side of the rectangle. I'll call it section B. So for that rectangle, length times width, the length is 10, the width is 6, so 10 by 6 will give me 60. And since this is 6 and this is 6, it's a nice perfect square. All 4 rectangles all the way around are going to be identical. So I've got 4 of those. So that gives me 240, and there's my box. All right, so now I just need the surface area of the sphere type part. I want to call that, it's called C. So for part C, surface area of a sphere is 4 pi r squared. So I've got the 4, I've got the pi, my radius is the 2.5, so I'm going to make sure I use the 2.5. So I got the 2.5, I'll square that, and I'll times that by 4, and I'm going to multiply that by 3.14, so I get a surface area of about 78.5, but that is if it was an entire sphere. It's not an entire sphere, it's only half of a sphere, so I'm actually going to divide that by 2. I want to cut that in half, which gives me an area, and I'm going to round off. It's an area of about 39. So that would be the area of the hemispherical type part right there. So what I could do is I could then put these all together. So if I put all three of these together, I've got the 72, I've got the 240, I've got the 39, and I put them together, I've got about 351. Let's clean that up a little bit here. Oops. My eraser, write that a little bit better. There we go. So 351. Now what I like to do is try and look for covered parts. So next I often look for is any parts that are covered, and I got two parts that are covered. There's the top of the box in the shape of a circle is covered, as well as the bottom of the hemisphere is covered. I didn't include the bottom of the hemisphere, so the only part I need to take care of is that circular part of the top of the box. It has to be subtracted from the total surface area. So area for a circle is just pi r squared. And there's a circular component on top of the box which is covered up by the hemisphere, so you can't actually see it. So if I just do pi r squared for that component, I will get an area of 25. So there's 25 that is covered up. Okay, so if I sort of took a top view of the box, the box is 6 by 10. The area of this whole thing is 60, and then I'm subtracting the part that's actually covered up by the hemisphere on top, which is 25. And some people would have done that at the very beginning. I like to just sort of look at my covered parts afterwards. That's why I just find that part easier. So I've put everything together. I've got 351 for all of my parts put together. I will subtract 25 for the part that was covered up, and that leaves me with a total of 326 yards squared, would be the surface area of my shape. People do this in different orders, sort of structure things a little bit differently. This is typically the way I like to do it. I find it keeps me organized, and then it doesn't really matter how you do it. You should end up with the same answer, around 326 yards squared. All right, so let's get rid of all of this. Delete all that. And bring in our next shape. So for our next volunteer, we are going to use this guy right here. Okay, so a box with a pyramid on top. And for this one, we are going to find the volume of this one. So we're just going to find the volume of this shape. So we've got basically a box in the bottom, and we have got a pyramid on top. So the box is really, really, really simple. Volume for the box type structure, volume is length times width times height. That's pretty simple. In fact, it's a perfect cube. It's 13 by 13 by 13, so that's pretty easy. So just 13 to the power of 3. So that gives us a volume of about 2197 inches cubed. Now for the pyramid, that's a little bit different. Okay, so for the pyramid part, volume for a pyramid is 1/3 length times width times height. Now the 1/3 is no problem. We have the length is just going to be 13. The width is just going to be 13, but we don't have the height. So we are going to have to try and find the height. So let's bring out another copy of that guy. I'm going to resize and make it a little bit bigger. There we go, something like that. Okay, so we can see a little bit easier what's actually going on. Now, in order to find the height, I am going to have to use a little bit of Pythagoras. Okay, now it's not super complicated, and we've sort of done this type of thing before. It's not going to be that big of a deal. So here I have this side right here. I know this is 12 inches. This is 12 inches right here. And what I can do is I could go straight down from the top right to the middle of the top of the square, and that's the height I'm looking for. But then there's also this side over here, and there's a right angle right there. So if I sort of bring that triangle out a little bit, if I sort of redraw it outside, that is the height of the pyramid, my right angle, and this is 12 inches right there. Now for this bottom part, that is just the distance from here to here, or the distance from here to here. So that's just half that distance. So half of 13, of course, is 6.5. So now that I know that it's just a little right triangle, of course I can use Pythagoras with that, and I can try and find out my missing height. So this could be your c squared, this could be your c over here, this could be your a, and this could be your b, whatever you want. A and b doesn't really make any difference, but of course a squared plus b squared is equal to c squared. So you've got the 12 in for the c, you've got the 6.5 as your a or your b, doesn't matter. You can then solve for the missing side. So if we solve for the missing side, we can find out the height of the pyramid is about 10 inches apparently. Okay, now that I have my height, I can finish off the rest of my expression up here. The volume is 1/3, the length is 13, the width is 13, and the height I just found over here, the height of my pyramid is apparently 10. So I can take those, I can put those all together. I got 13 times 13 times 10, and then I'll times that by 1/3, and you get approximately 563 inches cubed. Okay, so I've got my box in the bottom, I've got the pyramid at the top, so then all I have to do is take these two and put them together, and I will have my total volume of my structure, and give or take a little bit, that is going to be about 2,760 inches cubed for a total volume of the composite shape. Okay, one more volunteer, one more shape we are going to quickly look at, and that is this ice cream cone looking guy right there. All right, and for this one we are going to instead find the surface area. We're going to try and just find the surface area of this guy, which is relatively straightforward. It's pretty simple. We have two basic shapes and we'll just piece them together. So the first shape on top is a half sphere or a hemisphere. So if we find the surface area of a sphere, of course, is 4 pi r squared. I know the radius is already 7, so that's easy. So I've got the radius, so I'll square the 7, which is 49. I times that by 4, I times it by the pi, and I've got a surface area of about 615. Now the only thing is this is just half of a sphere, so I'm going to divide that by 2. So I'll take this right here, I'm going to divide that by 2, and that means just the hemisphere on top, rounded off, is about 308 inches squared. All right, so now I just have the cone structure at the bottom. Surface area for a cone type structure, just the outside of the cone part. We don't need to include the part that's in between the hemisphere and the top of the cone. So just that part is pi r s. Okay, we have pi, we have the radius, we have the slant, which is the 15. So we can put those together. So we got the 3.14, we can times that by the radius, which is 7. We times that by the slant, which is 15. And rounded off, it is a area of 330. So now all I have to do is take my two surfaces and put them together. I've got 308 for my half sphere. I've got 330 for the cone type thing at the bottom of my ice cream cone-ish type shape. Now put them together, and we're looking around 638 square inches for the surface area of the entire thing.